Okay, fifth grade. Here we are on page 17 of our SAB, lesson 7 of unit 1. And today we're going to be looking at what do we do when we have to add fractions that have different denominators, so they don't have a common denominator. And here you can see that we're starting out by using models to help us. These are great and you can draw them yourself, and this is one way that you can figure out how to change the denominator of a fraction. It's not going to be your fastest way. It's also not going to be your most accurate way. But I do want to show you these because it is really nice to have them in your head as we move forward to understand why what we're going to do works, why it works. Okay, so I'm going to zoom this in just a little bit here. We're adding 1/2 and 1/3. So right away we see that these two bottom numbers, the denominators, are not the same. We have to change them. We have to figure out what can we do to make them the same. So if I'm looking at 1/2, this model shows me how many sixths would be in 1/2. And then if I look at 1/3, I can see how many sixths would be in 1/3. How did they know to make 1/6 down here though? Do you guys know? They knew it because they could see that both 2 and 3 go into 6. 2 and 3 are both factors of 6. That's why it worked. So they knew they could multiply to get to 6 for both of these. So what would you multiply 2 by to get to 6? 2 times what equals 6? Okay, 2 times 3. All right, so we'll put the 6 in here. 3 is our multiplier. So we have to also multiply the top number by 3 as well. 1 times 3 equals 3. I'll be writing this out for you later, but right now, since we're looking at the model, we're mostly focusing on the visuals over here, and we can see, oh yeah, there's 1, 2, 3 sixths there for the 1/2. Okay, and then the 1/3, we have to multiply to get from 3 to 6. We would multiply 3 times 2 to get to 6. So there we have our 6, and then we have to multiply the numerator by the same number, so 1 times 2 equals 2. And now we have 3/6 plus 2/6. So these fractions here, they are equivalent of the fractions that are up here. We've just changed them so that we can easily add them. 3 plus 2 is 5, and so then we have 5/6. Oh, I just noticed down here, this is nice because they actually showed multiplying it by each one. So this is what I did in my head, but I like that they have the space here because we're going to need it soon. And I'm putting a rectangle around these because those are the magic ones. So again, this is just showing, oh yeah, we had to do 2 times 3 to get to 6, so we also had to do 1 times 3 to get to 3/6. Same thing, 3 times 2, 1 times 2. The common denominator, go ahead and circle this. This is a very important phrase for you to know. You've heard me saying it quite a bit. You heard me saying it in 4th grade. Now it's time for you to be able to quickly identify this. Well, maybe not quickly all the time, but at least very accurately identify. The common denominator is 6. Why? Because we changed both of these fractions to have the same denominator of 6. So that's what we're looking at there. Let's look at another one. This is one of the more tricky concepts, just to be honest, starting off 5th grade. So we really want to make sure that we have this strong. Here's our problem. 1/4 plus 2/3. Again, we can't just add 1 plus 2 because the denominators are not the same. It will not work. We have to change the denominators. So can you think, and obviously you have the model in front of you, but if you didn't have the model in front of you, can you think of something that 4 and 3 both go into? To use the correct math term, it would be, can you think of a multiple of 4 that is also a multiple of 3? And of course, in our model here, we can see it's 12, right? You could multiply 4 by 3 to get to 12, and you could multiply 3 by 4 to get to 12. Okay, I really love these models because it does really help. 1/4 is how many twelfths? There's 1/4, 1, 2, 3 twelfths. So I'll write my 3 twelfths there. 2/3, so here's 1/3 and there's another third, so 2/3 equals 1, 2, 3, 4, 5, 6, 7, 8 twelfths. So that's so nice when we have the model there. And again, you could draw your own models and do it that way, but it takes longer and it isn't always accurate when we draw fraction bar models, as we saw last year. Okay, so we have 1/4 and we're changing it to 3/12. This is just showing how the math breaks down. 4 times what equals 12? 4 times 3. So then you can see that our magic one, or our multiplier, to use the 5th grade math term, is 3, right? 3/3. So 1 times 3 is 3. What's our multiplier going to be here? What's our magic one going to be here? 4, because 3 times 4 equals 12, and 2 times 4 equals 8. Dun, da, da, da. And the common denominator is 12. Very good, because both new fractions have 12 in the bottom. Alrighty, you can do the next one down below on your own. It looks like they have 1/4 and 1/2 at the top, and you're changing the denominators. And it kind of depends which way you want to go on that. This one is to demonstrate that you could go to eighths or you could go to fourths. You might remember that a lot of times we've said, here, let me zoom in on this. Do we have to change both of the fractions or just one of the fractions? This is an example of a time when we really would only have to change one, because you can multiply 2 by something to get to 4, and then you wouldn't have to change 4. In other words, 4 is a multiple of 2. So play around with that one, see what you come up with. It will be different if you go from eighths to eighths or if you go from 2 fourths, but either way, you should come up with an equivalent fraction. Okay, and then explain why. Explain why you chose the one that you did. Here we go, number 4. Does 1/2 plus 1/3 equals 2/5? I really hope you're saying no, because if we have these denominators here, 2 and 3, we can't just add them up to get 5. We would have to change that fraction to get a common denominator. The 3 and the 2, it would end up being 6, right? So you would end up with something sixths. Okay, turning the page. Oops, I'm still zoomed in there. Choose a common denominator. So now what these are doing is we're adding the fractions, but we want to add them showing a common denominator. This is where we're going to set things up a little bit differently. And I hinted at this last lesson. Here we go. We're ready for it now. So let's check out number 5. 7/10 plus 1/5. I want you to set these up like this. Yes, it's going to take up a little more space on your paper. Yes, you'll have to write with your pencil. Oh no. But that is fine because you are 5th graders and you've been practicing showing your work all along. So does Miss Dye require you to do this? The answer is yes. And I just talked about myself in 3rd person. So here we go. Your goal is to get 2 new fractions over there. So I have added my fraction lines. Now, we need to figure out what our common denominator is going to be. I like to put little circles there, just so I know, okay, that's where my denominator is going to be. Now, looking at these 2 fractions, 7/10 and 1/5, am I going to have to change both of them or just one? If you said just one, you would be correct, because 5 can be multiplied by something to get to 10. So I don't really have to mess with 7/10. In fact, as I fill in my common denominators over here of 10, I'm going to go ahead and just write 7/10 up there. If you wanted to get really fancy, you could write it like that, right? Because we're just multiplying it by the magic one of 1/1. But really, you don't have to do that. That is unnecessary. 7/10 is staying the same. Now down here, same thing. We have to multiply it by a magic 1 in order to get to 10. So what is our multiplier going to be here? 5 times what equals 10? 5 times 2 equals 10. I add the 2 up there as well. That's my magic 1, 2/2. 1 times 2 equals 2. So now I have my old fraction of 7/10, my new fraction of 2/10, and I can add them very easily. 7 plus 2 equals 9. Denominator stays the same, So 9/10 is our answer there. Now, the reason they've given you these lines here is because they want you to show the new fractions. This is not how I'm going to want you to be setting this up. It's not enough space to do exactly what we want, but if you, like me, really enjoy making sure everything's filled in on your book, then you could still put those in. Just so you know, the requirement here is that you have the answer and that you show me with this style. I want to see it set up like that. Probably means you're going to need some scrap paper. I'm sure you can find some scraps of paper around the house. Okay, number 11, Bashir walked 1/4 of a mile to his friend's house and then another 3/8 of a mile to the park. Make a diagram to help you find the total distance he walked. So again, this is looking at things like we saw on the last page. So we could divide something into fourths to show the 1/4, the 1/4 there. And then we could divide the exact same length of fraction bar into eighths. Okay, and then we would show 3/8. Now, to find the total, how many eighths would be 1/4? 1/4 equals 2/8, right? So that's how you would draw a diagram, and then you would show 1/4 plus, you would need to change 1/4 to 2/8 is what you would need to do. Could you hear my wheels spinning as I figured out what I was doing wrong there? 1/4 is the same thing as 2/8, so that fraction 1/4 is represented by 2/8. 2/8 plus 3/8 equals 5/8. Now remember, this is not how you're normally going to set things up, but it is a very good skill to have, and sometimes the problems will ask you to make a diagram. If they do, now you know how. There's 2 more problems down below. These are all real world problems. I want you to make sure you write an equation. If you're wondering what that looks like, it's the same as up here. So you've written your 2 fractions that now have common denominators plus your answer. Let me know if you have any questions. Good luck, guys.